Welcome to another episode of The Front Row, brought to you by Martin Logan. Today we're going to be talking about, or continuing our conversation on HDMI with our special guest, James Chen from Kordz. Before we get into it though, let's hear a special word from our sponsor.
Bass that hits hard, fits anywhere, and sounds like it belongs. Martin Logan's Dynamo and Abyss series subwoofers deliver high performance and compact elegance with stunning precision and control. Martin Logan, bringing you truth in sound since 1983.
Welcome back. We're here again with James Chen from Kordz and Eric Wesley from AVS Forum. We're going to be talking about HDMI. We're going to be kicking things off with jumping right into HDMI 2.2 and then kind of progressing into some other things in regards to HDMI and how it works. So James, this is where I turn it over to you. If you guys want to know more about James, I encourage you to jump back and watch the previous episode, episode 6. You can learn a little bit about James and his history, but we're just going to jump right into it here. And James, I think we're talking about HDMI 2.2. So I will hand it off to you. And Eric, there we go. That's the right slide.
That's
so
the
James,
right slide.
Let's have at it.
I just thought I'd take this opportunity. Thanks for having me, guys. I thought I'd take this opportunity to just talk a little bit about HDMI 2.2 because there are a lot of people asking about it.
Lots.
And it is the new standard, and it is here. So we have a announcement. We have a specification on what it's going to do, which means we have all the authorized test centers frantically trying to find the equipment. And it does exist because DisplayPort's already at 80 gig and we already have 100 gig chips available. So the technology exists and all the ATCs are setting up ready for testing. But I thought I'd just highlight some of the new things to be aware of when we're talking about HDMI 2.2.
Okay.
The number one thing is that 2.2 only refers to the specification. It refers to the new test specification with which all the devices and cables get tested and certified. It's the reference standard. Devices that are called 2.2, 2.2 compliant, they may or may not support all of these optional features that are listed in this slide.
Now, were there optional features?
Optional.
Were there features that were optional also in HDMI 2.1, or is this new?
All features. So yes. So the answer is yes. I could submit a 720p stereo under HDMI 2.2, have it pass the requirements of HDMI 2.2, and it is a 2.2 device.
Okay.
Interesting.
720p stereo or less, 480, 480i if I want. It's part of the HDMI spec. I don't need to push it to 96 gig.
Now, that was the same for HDMI 2.1 and 2.0?
Correct.
Okay. Yeah.
So make sure when you're buying these devices or sourcing these devices that it's clearly in the specification what you want it to do.
Now, what are some of the biggest changes outside of the obvious with resolution and bit depth and frame rate and stuff like that, where that's kind of the sexy thing? What are some of the biggest changes that you're maybe, I want to use the word excited, but are notable in this new spec, I think, that may help with how things have gone in the past?
So one of the biggest changes is the higher bandwidth. 96 gigabits per second is the big announcement. It's almost 100 times the speed of gigabit Ethernet. This is 100 gig. This is 96 gig, effectively unbuffered in real time. Your internet is not.
Right. That's crazy.
There's going to be a lot of heat. There's going to be a lot of capacity that's required. There's a lot of power, increased power that's required, and HDMI has recognized this. But one of the exciting things about 96 gig is the capability. In the past, I've talked about multi-screen experience. I believe this is really going to activate this mixed reality, augmented reality experience, especially for sports, gaming, where you've got multiple channels coming in, combining overlays. We've got higher refresh rates for gaming. We're leaving this 4K, 8K no man's land, where we're really getting into 16K and potentially 32K, but 16K at reasonable resolution and color depth, that we can actually interact with the screen. It's now possible to create the initial stages of a holodeck where we can really immerse ourselves close, because we want to play. We want to have multiple screen experiences where we can utilize the screen not just for entertainment, but for feedback and for interaction and for input response. That's really where I think the exciting thing is. In order to do that, we have a new HDMI cable, which uses a new connector and needs even higher noise rejection capabilities than before. And it's not an HDMI 2.2 cable. Anyone telling you to try and buy a 2.2 cable, they have no idea, and they probably don't make it. That's one of the first indications that they're not a manufacturer, because HDMI has mandated since HDMI 1.4, so everyone's been given plenty of notice that every cable can only be named standard with Ethernet, high speed with Ethernet, ultra high speed UHS, or in this case, Ultra 96.
Okay. I did not know that.
Yeah.
News to me.
So yeah, if someone's saying, "Oh, is your cable 2.2?" No such thing.
Okay.
And what we say about that is, well, if you can't even, it would be like me calling Eric Fred at this moment. He's not going to turn around.
2.2
even if I'm
is
handing out hot dogs.
2.2 is the spec.
Yeah.
And then the cable is Ultra 96. Yep. What is this latency indication protocol? And then that's one thing I'm curious about. And then what is the optional 300 milliamp? Is that the same thing as the injectors we already have, or is that different?
That's different.
Okay. Are you able to
illuminate
us at all of that?
So LIP is a improvement on audio sync, and effectively, in simplistic terms, it's signal synchronization at multiple different levels. It's the first indication that HDMI has given me, proper solid engineering indication, that HDMI is willing to expand beyond point to point. They are actually recognizing transition devices, and it's a coordination of the transition devices. So even though we had lip sync correction in since 1.4, we still had lip sync issues and delays because there were multiple, if you used a projector, it took longer to get transmission back. You still had to go to the AV processors menu and manually adjust the timing.
Mm-hmm.
And the frustrating thing was when I changed media, sometimes the lip sync conditions were different. And if you've bothered to install a reference level system, anything above $40,000, right? I'm talking projector, speakers, the whole gamut, right? Which many people have. Those things kind of destroy the experience. It's the psychology of someone telling you a story or telling you a lie.
Yeah, you're getting pulled out of the moment.
Yeah,
the immersion is breaking.
So it's this synchronization of all the devices that's going to create cohesion in terms of the experience.
Now, is it able to recognize when it gets off? If it ever gets off? Is there any protocol for that? Or is it more of an auto lip sync where it's determining delays and latencies of other devices?
So, so the only way I can answer that right now is we don't know
Okay,
because we don't have any practical examples.
understood.
And because, number one warning, do not buy any HDMI 2.2 or Ultra 96 cables right now as of middle of August 2025, because currently they do not exist.
Yeah.
And because they
Listen to
don't
James,
exist,
guys. It's people trying to capitalize on hype that they don't exist. Okay, so
and one of the unfortunate things is even with ultra high speed cables, we are now just getting onto the cusp of experiencing 40 gig, 48 gig
yes,
right now. But the technology came out in 2021. So do you think if it doesn't work now, the manufacturer is going to go, oh, well, that's a warranty claim. You've
yeah,
been using it for 4 or 5 years.
yeah. So what about the HDMI power cable? Or cable power, I should say.
So like many HDMI improvements, this HDMI cable power is optional. Instead of 50 milliamps detected at the sink side, it is possible for the source, because you cannot draw power from the sink,
To be
technically,
compliant.
5.1
Yeah.
line, to be compliant. You can draw up to 300 milliamps from the source, but both the source, the repeater, and the display need to support that. Otherwise, you could shunt too much power. I know cable is drawn, but but you could have power irregularities, and you could overdrive the circuit, and you could effectively destroy the HDMI socket on your TV.
Okay. Now,
And and I don't know how many eARC sockets TVs have these days, but my TV only has one.
yeah, most of them only have one. So is it, but that could theoretically help in longer cable runs, I would assume, as long as the cable is able to handle that.
Yes,
That
it
power
is.
coming from the source.
It is HDMI also recognizing there is a possibility of longer cable runs and longer devices. What people do with that power, our industry is famous for trying things that it's not supposed to.
No.
So, and the other thing is it is optional. So will electronics manufacturers make their devices more expensive? I say this tongue in cheek, be less competitive in the market, and put these things in. Is it the demand for, because at least 90% of the time it's a TV on a TV cabinet
Yeah.
with a Blu-ray player underneath.
Mm-hmm.
So most of the time, it may or may not be implemented. But it's a great start. But it's just kind of like the end of the last episode where we talked about Ethernet in HDMI. When it was initially implemented, most of the cables had it because it was kind of mandatory, and it would be stupid not for a cable manufacturer to not have it.
Right.
But for the electronics manufacturers to spend time engineering it, which costs money, pay, even if it's cents, to add it to a circuit, to complicate something that is already so complicated,
Yeah.
and then make their devices cost more or potentially have more troubleshooting issues. Are they willing to do that? And I say that tongue in cheek because there will be some really good manufacturers that do recognize the problems that professional integrators have that will implement that.
Right. Okay.
And I wish them all the success.
But the key here is optional. Yeah.
Yeah. So both the source, the cable, the repeater, and the sync device have to support it.
Yeah. If you have a repeater.
Yeah.
Yeah. But every device, you're effectively saying every device in the signal chain has to support it, like it does all this stuff. If it doesn't, you're falling to the lowest common denominator.
Correct.
Got it. Okay. Understood.
So that's just a quick update on HDMI 2.2. There'll be plenty more news as as devices come about. I don't think we're going to see anything this year, but potentially, definitely next year, we'll start to see some things come through that we can start to experience. Whether you need them or not, whether we need 16K or not, really depends on your situation. Again, we don't have any, you mentioned we don't even have any 8K source material really. So it's too early to say.
Okay.
But also to note is 96 gig is not going to be easy to implement. Cool.
Thanks for that.
And also just as a quick revision, these are all the connector types. So if we go to the next slide, just a quick slide on these are all the connectors. There's a type B connector, is a dual link, a wider connector, but that was essentially dropped. So we've got the micro connector, which looks like a micro USB. I'm sure many of you plugged it into the wrong socket and caused some issues there.
Why doesn't this work?
It's a very small connector used in cameras and things like that. Type C is also used in cameras, media devices. Type A is the standard one that we all see, and E is the automotive one, which some car manufacturers use. There are cables that go from A to C, A to D. Most of them are passive and short length.
So is it the same number of pins, just different sizes?
Same number of pins.
Okay. Just different orientations and sizes and connector heads.
Yep.
Okay.
Yeah.
So the body of the cable is effectively the same. It's just the cable heads.
Yeah. The smaller the connector, the lower the grip strength. So it's either really loose or it's so firm that it gets stuck in order for you to have a positive connection. So that the size of the connector relative to what you're doing with it is an important engineering piece. And HDMI licensing have an exact tolerance for the receptacle that the HDMI cable goes into, but it has a variance for the HDMI connector on the cable itself.
Now, to be clear there, you're talking about the shell and how that fits into the connector head. Well, the thing in its entirety and how snugly it fits, not like pin separation and stuff. You're talking about how that fits in the receptacle and how it's held there. Okay.
Correct.
Right.
Because it needs to allow for the actual manufacturing.
Yeah.
The socket's usually a folded piece.
Mm-hmm.
So that can be made relatively exact, but the connectors are usually stamped, or in the case of more premium connectors, they're die cast.
Is there any issue?
Is
there any issue with the pins being too close together?
Yes.
Does that present itself on the smaller connectors?
The capability of the smaller connector to do 96 gigabits per second is going to be
limited,
close to impossible.
And is that because of interference?
No, because to do more things, we need better quality power.
Mm-hmm.
And there's only so much power you can push up a smaller connector.
Ohm's law again.
You have,
look at that.
Yeah.
It keeps coming back.
Yeah. Yeah, but it's resistance over distance.
Gotcha.
Yeah.
So I guess why not make the cable head larger?
Because we tried that with DVI. We tried that with VGA.
Mm-hmm.
Didn't work. People were always trying to cut the connector off and site terminate. And I wouldn't try to hand make my computer, my laptop.
No.
By resoldering the joints. I don't know why people would try to do that with a cable that's supposed to do 100 times the speed because you're never going to be as 100 times more accurate.
So what you're saying is that HDMI is kind of stuck because people are dumb.
We need to find
Might be one way to put it.
with all engineering problems,
Mm-hmm.
there needs to be a balance. Every cable is like a bridge.
Yeah.
We need to understand what we're trying to carry. Is it tanks? Is it just trucks? Is it just cars? Are there occasionally buses? How long does it need to last? How long is the span? Once we understand these variables and then conditions like wind variations and site-specific geology, i.e. electrical noise, bend radius, all those kind of things, we can then calculate the bridge and be sympathetic with, hey, this cable needs to actually be installed. It needs to go through a hole in the wall. I need to run it through conduit. Well, what is the practical limit that we can envisage that this a standard HDMI cable these days is between 18 and 25 mil, which would fit in most 1-inch conduit. You need to be very specific about which hardware store you go to, because some sell you an external measurement of 1 inch, some sell you an internal measurement of 1 inch, and that's the difference between success and failure.
Yeah, sometimes. Yeah, absolutely.
Yeah. So I think the connector is a good size for a solid fit. It gives us, it allows us to. One of the things I dislike, it's a personal opinion, I dislike HDMI connectors with bumps or with locking. And the reason why I dislike that is because when HDMI was born, there was never locking. I tell this story. It's like when RCA connectors were born, there was no locking. Someone envisaged locking RCAs because maybe they fell out. And somehow we always use the locking RCA on our subwoofers. And when disconnecting our subwoofers, 2 or 3 years later, because we had to move it somewhere else, we forgot we locked it. So we pulled harder and the socket came out. And when the socket came out, it wasn't just a cable problem. It was an 80-pound beast. I then had to lug out, down some stairs, back out, ship it to the supplier, or, try to open it up and fix it myself. But I couldn't fix it where it was sat. Well, I'd try, but in the end, it would, you have to pull things apart. So locking, I don't think for HDMI works. Bumps, it's a solution, but once those bumps go into a socket, it expands that socket.
Yeah.
And if that socket just happens to be your MacBook, A, good luck trying to pull it back out. B, good luck trying not to damage that MacBook. And good luck trying to use that receptacle for any other cable.
I feel like James is talking from firsthand experience, that this may have happened to him in the past. And that MacBook may have become a projectile coming across as it ceased to work because HDMI ruined it.
Oh, you mean the time where I had to pay for someone else's MacBook and had to replace a cable whilst recovering their dead cat from under their house? Yes, I've done that.
That is a story for another time that I do want to hear. Okay.
Yeah. It was a dark and stormy night. All right, let's keep going. So I want to talk to you a little bit about, remind people about the different HDMI devices. So, I'm sorry it's taken so long, but we're still building. There's kind of a lot to get back to basics. But I also remind people with troubleshooting, it's always important to get back to basics, write things down, do flow charts, take your time to think things through, because these technologies that we implement will just automatically do weird and wonderful things, or not very wonderful things. So the HDMI devices, yeah, or nothing at all. No, they're doing something. It's just not what we want them to do.
Okay.
So the first thing we have is a transmitter, and a transmitter is usually a source device. You know, your Apple TV, you know, even your phone these days could be a transmitter if you plug it in for your Spotify and things like that. So it generates HDMI signal. It takes the video part from the GPU in your device. It takes the audio part from the DSP or the SoC, encodes it using either 8-bit, 10-bit encoding or 16, 18-bit with FRL into TMDS or FRL, and then it encrypts it using its HDMI encryption. And then it's able to, with the right handshake, which we went through last time, it's able to transmit that information out for us to experience.
Okay.
The second device is the sync device, which is usually a display, but it could be an AV receiver, or it could be an audio amplifier. And it accepts the HDMI signal. It deserializes the TMDS or FRL. In the case of FRL, it unpackets the box and, you know, recreates the audio part and the video part, and then it decrypts the HDCP, and then it displays. The third device that was introduced was the repeater. These are the three main common devices that we have, and it's usually something like an AV receiver. A repeater is usually both a transmitter and a sync device. It takes something like audio and then repeats and reclocks and regenerates, say, the video part, and transmits it to the video source. A repeater could also be a scaler.
Okay.
And it may reclock, deskew, fix the signal, equalize it.
Now, when you say they may or may not contain HDCP keys, does that mean sometimes they won't work, and or they're just going to pass them through?
So it may decrypt the audio HDCP and pass on the video. So some devices have got pass-through HDMI and some don't. So the pass-through, they're still a repeater because they're still active, but they don't actually change anything.
And you say active because they're powered.
Because they're powered, yeah.
Okay.
So it may fix. So for instance, you know, an HDMI 5-volt injector, because what it's doing is the source might not have good 5-volt, or it's got just compliant 5-volt under the plus minus 5% rule, say, right? 50 milliamps, 55 milliamps plus or minus 5% may or may not get you there. So you put in a 5-volt injector or an active HDMI cable, and then the HDMI cable is actually technically a repeater.
Okay.
Because it's passing, it's not changing the TMDS or FRL, it's not doing anything of it at all, but it's fixing or adding to the 5-volt line in order for it to work.
Theoretically, though, could it be, depending on the length of the lanes or the length of the solder joints that are in there? Because if they're different, you could affect timing, I'm assuming.
Cables generally don't fix timing. Active devices could fix timing.
I'm not saying fix, I'm saying make it worse. Because if the joints are longer, you could throw off in nanoseconds timing when things are arriving. And because that's something that I've talked to Jeff Boccaccio at DPL Labs about. When you're trying to measure things and you're putting on your joints to measure, you're technically screwing up all of your power and your timing because you're lengthening connections, which can throw things off. And when things are this finite, anything you do can create potentially a negative scenario.
Correct.
I'm not saying that's necessarily what they do. Just
Oh, they do.
okay.
Everything
They do.
Everything you add into the circuit changes the circuit from its original.
So is that you saying in a way, if you don't need an injector, don't use one?
If you don't need any device in the middle, don't use one.
Don't use it. Okay. There you go.
The simpler, the better.
Yeah.
In fact, if you are fortunate enough to have a player with 2 HDMI outputs that support the upcoming 2.2 spec, which has lip function, you could time both outputs perfectly. So we have additional devices that we've added to make our life simpler. We have switches and splitters, which generally have some form of EDID management. A switch is something which takes multiple HDMI inputs and switches the source. And a splitter is something that takes one source and splits it into multiple outputs. And a matrix switch is generally a combination of switches and splitters. And they need complex EDID management because you're now handshaking with many. So you got one source, maybe handshaking with 8 TVs, like at a bar or in an outdoor living space, or you've got a splitter which needs fast switching because it's switching between source devices all the time. So handshake protocols in switches are very, very important, that they actually properly toggle HPD.
HPD meaning
Hot plug detect.
hot plug detect. Yes.
Yeah. So remember, in a switch, all 4 devices are already plugged into the switch, already handshaked before, already active.
Yes.
When you switch from A to B, if it doesn't toggle, it's going to keep all the EDID of A, but then
yes.
the HDMI signal's like, hang on a minute, you've just switched HDCP on me. Sorry, no signal.
That makes sense.
And splitters, they may actually copy HDCP protocols across. They just handshake with 1, and 2, 3, 4 output is an emulation of 1 in order to make it work. And HDMI, I think, don't officially recognize that. And then there are redrivers and retimers. So, they're basically conditioning electronics. So a redriver, like a 5-volt injector, boosts amplitude of signal. It may or may not equalize IPAT. So you've got a number of those. A retimer fully reclocks and regenerates. So it takes the signal. A scaler is a retimer. So it takes the original signal. It completely takes all the signal, processes it, makes its own output for the display. So video walls typically use retimers. Because every single panel has got its own unique resolution depending on which module you choose, how big the wall is, and all that kind of
That's true.
And then the last electronic device is bridges and converters. So bridges and converters are, typically convert HDMI to other standards, or they convert other standards to HDMI. And the most common are DisplayPort SDI. There's new USB-C alt mode. So USB-C alt mode is typically for DisplayPort. So USB out of your laptop, it's USB to USB-C. It's DisplayPort, but that DisplayPort can then be converted to HDMI for use with your TV.
Got it.
So now that we've gone through electronics, just the electronics part.
Ryan's favorite
What do you
part.
think could go wrong?
Everything.
With all these things talking to each other. So I'm not trying to scare people. I'm trying to make people aware. And first part of making people aware is really understanding the conditions with which we're currently at.
Before we jump into what can go wrong with HDMI, a quick word from Martin Logan, our sponsor.
This episode is brought to you by the Martin Logan Dynamo and Abyss series subwoofers. Packed with high output, high precision aluminum cone woofers, powerful amplification, and ultra precise DSP, these subwoofers deliver deep controlled bass. They're built to perform and designed to fit seamlessly into any space. Martin Logan, bringing you truth in sound since 1983.
Welcome back. We're about ready to jump into what I think is going to be my favorite topic. And funnily enough, it is, I think, what a lot of people, or not what a lot of people, but what is most unknown in the industry is what can go wrong. And what does it look like when those things go wrong? Because as of right now, at least a lot of people that I know professionally and enthusiasts and casual Joe Schmo from down the street, nobody knows what is going on. The rigmarole goes, we'll just unplug it and replug it in, and you just kind of throw things at it and throw darts in a dark room and just hope something sticks. So I'm excited to know what can go wrong and what does it look like when those things go wrong and what causes those things when they do go wrong. James is here to enlighten us.
So we're going to talk about some of the things that can go wrong.
We're going to talk about more.
If we talk about all the things that can go wrong,
most common things, we'll leave it at that.
So yes, welcome to What Can Go Wrong with HDMI, episode 165.
This episode.
Ryan, it's a great segue into this next slide. HDMI was established in the past, and we've got slides on how it came to be, but I won't bore you with all of that knowledge. But HDMI came really at the birth of 1080p. In the last few years, only in the last few years, finally 1080p worked.
Think about that for a little bit, though, because 1080p was introduced around and before 2006.
Yeah.
And then it kind of became the norm.
Mm-hmm.
That was almost 20 years ago.
Mm-hmm.
And James is saying it's just now working.
Yeah. And so what did we do then? What did we do, Ryan?
We lost our hair.
1080p was never enough, wasn't it?
We wanted more.
We wanted this thing called 4K.
I'm not going to have a beard by the time 2.2 is implemented.
Yeah.
It's all going to be gone. I'm going to be Mr. Clean.
We went from 1080p, which, by the way, was called 2K, and then somebody in the marketing department went, "Oh, 2160p. That's too hard to remember. We'll just call it 4K." Not only did we go on not only did we go on a naming convention rant, but we complicated our lives by making it 4 times more difficult because we've got 4 times the resolution.
Yeah.
And that's just the resolution. At the birth of 4K, we also introduced HDR, high frame rate, thanks to, Peter Jackson. We wanted more. But the past expectation has always built on the mantra, which is printed there, as long as it works. I plug it in as long as it works. And I remind people, working reliably always are 3 different achievements and cannot be collapsed into one.
No.
And what we want as professionals is always, as always, as far as it can be, right? Because as long as it works is not really an empowering situation. I don't know why, but always around Christmas time or New Year's, clients get drunk, something happens, we get a phone call. Every other day, it just works. Well, not every other day, but most of the time, right? maybe as a joke, and this is a troubleshooting tip. Maybe we should just set remotely that those systems only do 1080p on those days.
How many people you think would actually notice?
Very small percentage.
Yeah.
Because the amount of alcohol that they've already imbibed will prevent them from knowing.
I mean, a lot of the times, I don't even know that fidelically from people's main seating positions that they would notice 4K versus 1080p in a lot of situations.
Yeah. I don't think a lot of people notice. Like, you know, when you go to an Atmos cinema or theater and you pay extra for the ticket, do you realize it's in Atmos or is it 7.1? Because it does vary between.
Yeah.
That's true.
When Avatar came out, did you know which parts were 3D or which were not?
Yeah.
Because you're so bought into the storyline and there's so much going on. Like 16 channels of audio, really? And high resolution HDR? Sensory overload. But, I mean, subliminally, you'll know the experience when it's visceral and you know, we've all had experiences where our hairs stand up and go, oh, this is, I was going to insert another word, unbelievable.
Yeah.
So, but as long as it works, is not going to deliver that experience. No. It's so far from delivering that experience.
Yes.
And we're not even talking about buying hi-fi cables. We're talking proper engineering practice here and process. So this is the integrated view, but let's look at the next slide, which is the manufacturing view. And the manufacturing view takes on this view. I want to sell more devices, therefore I need to be different. Therefore I need to push the envelope. Therefore I need to offer the market things that they don't need, things that currently have no standards, things that are made up, they're more colorful. What a wonderful experience. Sell the sizzle, not the sausage.
You know how many arguments I've seen because of that?
But what does that do to common conversation between devices? You know, I heard a really interesting statistic the other day, and it was something like Samsung as a brand touches 80% of the world's global population.
What?
Yeah.
You mean in some capacity?
In some capacity. Think of that as an AI enabler. If there was any brand in the world that could enable artificial intelligence on a firmware update. Okay, now I'm scaring everyone.
So you're saying Samsung is actually Skynet? That's a joke, Samsung.
It starts with an S. And it's not Sony. So you know, they're all trying to make a difference. But marketing, engineering and marketing are two separate departments. There's no rigidity. Like with engineering, we're doing fact-based information that has been tried and tested over years, if not decades, applied that technology to make a bridge that does not collapse. But there's many cases where, you know, we push the envelope to try and give people an experience of what it could be like without giving people the actual experience.
Right.
Exactly.
You know, examples, you know, cables with gigabit ratings that are not the certificate, like odd data rates, like 40 gig support or 21 gig support. You know, that's nowhere
right
in the specification. So if they're making this kind of stuff up, they can't be an adopter, because being an adopter means that I have a legal agreement with HDMI to comply. And if you're not an adopter, which adopter are you using or trusting which third party are you now trusting to go and make your stuff? Clearly, you're not making your stuff.
Right.
Because you don't know what you're talking about.
You're just using marketing speak to get people to come to you as opposed to somebody else.
Yeah, and it's part of the game.
Yeah.
I get it. It's part of the real world. Who shouts the loudest?
Yeah.
Is going to
Normally
get
how
the
it
most.
goes.
You know, the last one, promoting devices just using HDMI version numbers, or calling cables with version numbers. We talked about correct labeling and incorrect labeling. And these things are easy to check. The thing is, HDMI is now everywhere. It's used by pretty much every single device. So simplification is required. And we talked about transitions and things like that. Consider every transition point and a complexity. So if one pin is 1% longer and I have 1% more solder and the cradle was 1% out and the twist rate is 1% out, and I've got 5% noise injected, which is kind of like real life, and I've got exactly the same on the other side, that's why I've got in excess of 3 dB of insertion loss in every single HDMI cable. So how do we lower that noise floor? In cinema design, we're talking about how quiet we can make the room.
Yeah.
The lower the floor of the noise, the more information that gets revealed above it.
Yep.
It's not about playing louder, because once you hit more than 96 dB, fatigue, unless you got a 50-inch sub, then you can't hear it. So 100.
You're deaf anyway, so it doesn't
great.
I was gonna say the 96 dB is too low.
Yeah, but no, I'm talking about consistently.
Okay.
Right, I'm talking about average sound output.
Oh man.
Right, reference level 106 dB.
Stupid
right?
loud at 96. If you're maintaining that as an average, good lord.
Yeah. So we want the quiet bits of the movie. The moment before the war, the attack, the bullets fly.
Mm-hmm.
That's the moment that creates the scene.
Mm-hmm.
It's the quiet before the storm.
It's funny you think about this all on the sexy applications like the huge room and the sound and the video, but you don't think about it on the technologies that make everything work.
Yeah. So let's get into compliance. Compliance is the least talked about issue because not a lot of people understand compliance. Compliance is really only for the brands, and it's only for the brands that are adopters. If you're not an adopter, you don't need to be compliant.
That seems like an unfair advantage.
It is, but
two people that don't know. Yeah.
Yeah, that was the way it was set up. As long as you use a compliant manufacturer in the chain that outwardly is compliant, then you're okay. And by the way, compliance, you only need to test the product once with ATC, and they sort out the compliance. They test your product, and then you do something called a self-test. So what do you think happens to that self-test? It's annoying, really. I'll stop doing that. What happens when you do that? What happens when a factory is doing a self-test and is trying to be more profitable and efficient, and is from a distant country? You're muted.
Gee, I wonder what happens when that occurs. Who would know? Who would guess?
Does that self-test even happen?
Correct.
It happened.
Yeah. Here's a challenge I throw out to a lot of manufacturers of electronics out there that are not, that are not tier 1 manufacturers, right? A lot of tier 2 manufacturers that get third-party products manufactured. My challenge is open the golden sample that you got when you commissioned the engineering and the build, and sometime later open the latest version and see whether you can find that it is exactly the same inside as you specified.
It's true.
And if it isn't, why? Is it because those chips weren't available and people were trying to manage their cash flow? and they just substituted something? Or is it because they lost compliance with or they couldn't get a supply from a certain supplier? There's all these business conditions for we used to, Kordz used to make electronics, right? And we used to third-party manufacture them, and I was shocked when I opened one of our boxes to find there was another brand's logo etched on our circuit board.
Wow.
And at that moment, I was like, I have no control over this. I'm not empowered to have integrity around products.
Mm-hmm.
Let's just do what we know. Let's only do what we can make.
Yeah, that makes sense.
So I just got rid of all that.
But the word that they like to throw around is tolerance. It's within tolerance, but is it really?
Yeah. So the labeling compliance. Labeling compliance. It sounds simple, but if you can't even call it what it is,
mm-hmm.
or if you can't label it correctly, then clearly you don't understand what it takes.
Exactly.
And when it comes to cable compliance, the cable's a passive device. So when you label something outside of spec, say 30 gig or 40 gig, it's not actually doing that.
Yeah.
It's the electronics on both ends that are in control of that and doing that.
I was going to say, just looking at those examples, I see a lot of 24 gigabits bandwidth and 120 hertz refresh rate on a lot of packaging.
Yeah. Tell me how a passive cable can do 100 hertz, 120 hertz, please.
Now, one thing that I don't think people think about in regards to what you're just talking about, because it's the source and the sink that are actually defining what speed things are going to operate at, the cable doesn't tell anything what it can do, right? That's unless it's running a speed test, it's not going to define, hey, this is what I'm able to do. So if the EDID says, hey, I'm capable of this, and the source says, all right, I'm going to send that to the sink, it may just not work because it's not doing what it should be doing. And it leads to a lot of situations where people end up blaming the wrong part of the signal chain.
Exactly.
Ask me how I know.
You know because you know. That's why you have no hair. All right, so we've got a couple of slides to go through, and then we'll call it probably.
Okay.
Yeah. So pretty quick. Some of the stuff we've already covered: cable length and speed. So a reminder that an HDMI cable is expected to support 100 times gigabit Ethernet now. So just have a think about that in real time, often without buffering, instantaneously at the push of a button. Because
that is crazy.
Any more than 1 second, you're going to push the play button again. And what does that do to your programming?
And if it doesn't work that second, you're going to be like, what's going on?
Bandwidth drops away very sharply with length. There's a point at which people have talked about the cliff effect. So bandwidth drops away very sharply with length, and we'll talk about voltages and things like that in the next one, right? 8K now is achievable up to 100 meters, but the compliance part of 100 meters, yes, it can maybe do 48 gig to 100 meters. But think about what we talked about before with HTCP, how it needs to respond within 7 microseconds. So technically, I think it's like 430 meters is roughly the limit of an AOC. Like people are talking about 1,000 meter AOCs. If you disable HTCP, no problem. But part of ultra high speed compliance is eARC support. It must support eARC. And eARC, technically, the limit is 20 meters. Reliably. I'm talking about compliant to HDMI's specification, not just some sticky label that says eARC. Because yes, they could legally argue, well, the cable's in there. It's just your TV's not capable of it. It's not reliable always. And when we turn on amplifiers, right? I'm talking about audio amplifiers. Voltage output sometimes varies. Why? Because power input varies. Sometimes I have 115 volts. Sometimes I've got 105.
So how, if it has to meet these specs, how does a cable get certified that's 100 meters long if it technically can't really do eARC at that distance?
It can't. So in our case, we, like you talked about Jeff Boccaccio, we use someone like Jeff Boccaccio for DPL to ensure the compliance for the 48 gig part. But at 100 meters or even 50 meters, I don't think anyone really wants eARC. Because the projector is at that point not the source. If the projector is 30 meters away from your viewing position, from your screen, you've got a big screen. So you're running different sources. So there's a practicality of it. A 50 meter cable to support eARC, 12 gauge wire pair, and you've all used 12 gauge speaker wire. Imagine installing that, how stiff it would. The cable would push the projector out of alignment. You'd have all sorts of mechanic problems, have all sorts of insertion loss. You're laughing because you've experienced it.
Yes.
Guaranteed.
I'm imagining certain passive HDMI 2.1 cables that are very long and very girthy.
Yeah.
Yes.
Yeah. Yeah.
But is this how, I'm assuming, and maybe we'll talk about this later.
Yeah.
Is this how, because of how the HDMI spec process works, you can test one cable of a certain group and then every cable of that group gets in because that one met it?
Yeah. 1.4 specification, cable CTS, was that you could test the longest length for an engineered thickness of wire and specification of wire, and every subsequent shorter length would be certified.
Okay.
With 2.1 and 2.2, every single length has to be has to pass.
Has to be certified.
So the certification process is even more expensive. So it's between $6,000 to $10,000 to do a test, and if you fail, you have to do a retest. So you know, a cable manufacturer with 20 different lengths, that's 200 grand's worth of certification potentially. You know, it costs a lot of money, which is why a lot of people are going, well, I'm just not going to certify. But non-certification requires means potential reliability issues. There are some circumstances where, like, you know, we have a 50, 100 meter HDMI cable that we know we're not going to pass eARC, but there's a practicality of it. So we look to DPL to certify that, because self-certification for me, I feel like it's patting myself on the back for my own achievements. You can acknowledge yourself every time, but that doesn't mean it works, right? I can be the best football player in the world in my own head.
Yeah.
That is not reality.
Now, when you're saying self-certification, you mean the company certifies itself, not what you're doing with DPL Labs.
Correct.
Okay.
Correct. Third-party certification is the only way to verify independently that your product works.
Credible third-party certification, because not every third party is credible.
So other things with cable length, it's, you know, we increase diameter of cable for to offset resistance over distance, Ohm's law again. But like Ohm's law, with short cable runs, we can cause something called EQ saturation.
Yeah. Goes both
So
ways.
with HDMI 2.0, there was this equalizer enhancement mode, which in some display devices you can't turn off. So you can actually inject too much.
I remember
signal.
when that came out.
Yeah.
Mm.
Which is why a lot of brands say, well, don't use a cable that's under 2 meters. Well, if the cable is balanced correctly and made correctly with the right gauge of wire inside, you can make a 25 centimeter cable. It's not a problem.
Yeah.
But you need to go to the effort. Remember, different engineering, different certification, more cost.
Yeah.
So solutions can mostly be solved by throwing money at it and doing it properly.
Yeah.
Right. Yeah, that's cable length and speed.
Now, what about the optical cables? Because you got that one thing down there that we haven't talked about yet.
Well, optical cables have limitations because you've got to. Well, we talked about the 430 meter limit in terms of the HDCP, but with optical cables, unless you're talking pure optical, right? Pure optical.
Which there are very few that do that.
Yeah. Pure optical cables have generally 7 or 8 optical conductors or optical fibers in there, and no copper. Right. Most HDMI cables have got 4 optical fibers in there, and the DDC and the e-arc part of it and the grounding and all that kind of stuff, that's still all copper or tinned copper or tin braid, and they will suffer over distance.
Now, to be compliant, though, those purely optical cables can't be, because the sync isn't powering both sides, correct?
Yeah, once you go over a certain length, you can't get compliant, because part of being compliant is the support for e-arc.
But what I mean is, because the sync has to power both sides of it has to power both sides of the cable, correct?
Yeah. So
and
the
to
sync
do that, a fully active fiber optic cable that has no copper can't do that, because you can't transmit power over fiber.
Correct.
So
you need to have power on both ends.
But that comes down to a hack of, is it a way around the power transmission to get it over there in order to
not with a fully fiber.
Well, I meant like injecting the power on the other side instead.
If it's fully fiber, there's no copper inside, so you can't even inject the power. If it's a hybrid cable, you can do that. It's not compliant to inject any more than 5 volts. And the other thing is, you need to be careful, is you're injecting more than 55 milliamps. You could, because remember that 5 volt line is still part of the handshake.
Mm-hmm.
You could overdrive that signal and cause handshake failure.
Now, you brought up 5 volt, but the sources, I'm assuming, if I remember correctly, there are a decent number of sources that will actually put in more than 5 volts.
Yeah, there's a lot of they'll go up to 5.3 roughly.
Yes,
like a generalization. And there's a lot of sources out there that you could draw more than 100 milliamps, but achieving 50 milliamps at the sync device is the requirement.
Yes, but could you, if you're pushing too much power from the source, overdrive the sync device?
You could.
Yeah.
You could cause a disruption, and over time you could burn out the circuit.
Do you think that's more prevalent than people think, with overdriving circuits and seeing degradation?
Well, certainly with short cables, yes. With longer cables, I don't see it that often.
What about with the source side of active AOCs? Could they technically degrade if they're receiving a signal that's too hot?
No, because the devices generally draw power on what they need. Now, you could have an AOC that needs more power. There's a lot of AOCs that need, when you measure them, they don't kick on until you turn. Then you provide more than 100 milliamps. In which case, it's trying to get more. It becomes the screaming child.
Mm-hmm.
Where it's always trying to get more than the source can deliver, and after a while the source will just either say no, or it'll just kill itself trying.
Okay. Because I know there's a lot of times where people will say, well, this worked for a while and now it's not working.
Yeah.
So I'm assuming that has to do probably with heat and things deteriorating over time, more than likely being power related.
So yeah, one of the things with electronics and cabling is that you when you use it, you're applying heat. Yeah, so the more heat you apply, the more you're baking everything.
Mm-hmm.
So it's like a piece of bread that you put in the oven, right? You can put it in the oven, at very low temperature, say 80 degrees, right? But in terms of Fahrenheit, let's say it's 160, it'll still toast. It might just take 45 minutes.
Right.
So electronics are like that. They've got a shelf life. There are, even though it's sealed, most of them, there's a reaction time with a lot of things, and cables are kind of no different.
What is the next topic? Or I think it's more on air modes, I would assume.
Yeah. So the next thing I really want to talk about is what happens in manufacturing.
Mm-hmm.
So I want to talk a little bit about manufacturing tests and how your products come off the production line, and what the manufacturers generally do with those. We'll remind you of proper labeling. And then I want to do a little exercise on HDMI pedigree, so that you understand through a practical exercise that you can all imagine or try yourselves, of what is, we talked in theory about what goes on in an HDMI cable, but I want to give you an exercise in terms of like what happens, and then I want to show you what is actually inside a lot of HDMI cables, what it actually looks like on the inside. Okay. And then, that's kind of like the next one. And then after that, we can talk about jitter.
Jitter. And when things go wrong, what does it look like? Yeah.
Yeah. What does it look like? And, if we want to go deeper, we can talk about shark fitting and signal condition loss and all sorts of stuff. So, like I said, episode 158.
We'll get there. I think it's important that people know this stuff. Nobody else is doing it. So,
So thanks again for having me. Sorry if I've got to go today, but it's been great sharing knowledge. I'd love to hear from your audience in terms of what they'd, if there's an opportunity, what they'd like to know, if there's any questions. Mm-hmm. I'd love to have a Q&A time. I'm constantly learning myself from the market. Okay. Having had practice, being in the market at different levels. But like for me personally, it's very important that we stay in touch, that we continue to have dialogue, that we continue to share our experiences, so that we can build this dream of mine, which is a connected world that works.
Keyword, that works.
Yeah.
Yeah. A lot of people like to say the connected world, but they leave out the works part, which is kind of important.
Yeah.
Because it can be connected and it all be silent and black, and that's not very fun.
Yeah.
But James, thanks again for joining us. It was a huge pleasure to talk to you. You gave us a tremendous amount of your time today, so that was great. We will come back probably after CEDIA would be my guess, because CEDIA is looming. We talked before the first video of how anxious I am about the whole thing, because I get to go build stuff and be out there for over a week. But CD is fun. So we will come back and we will continue the HDMI discussion. Eric, thank you as always.
Yes, thank you.
But before we go out, a quick word from our sponsor, Martin Logan.
Martin Logan delivers high-performance audio that fuses cutting-edge technology with sleek, elegant design. Engineered for audiophiles and home theater enthusiasts alike, Martin Logan products bring every sound to life with incredible clarity and power. Discover more at martinlogan.com and visit a dealer near you. Martin Logan, bringing you truth in sound since 1983.
And thanks again, gentlemen. James, thanks again. Eric, thanks again.
See you at CD Expo.